Okay, my name is Aaron Brooks, and I'm at the University of Idaho in the Bio and Ag Engineering Department. And this is some work that I've been doing with Ryan Boylan, the REACCH grad student here. We are both on the Objective 2 monitoring team, but I'm not going to talk about monitoring today. I'm going to talk about how we're going to take some of this monitoring data and develop a tool that how can we access this, some of the lessons learned that we've got in this in the monitoring we have. And we're charged is to look at the transport of carbon by water, either by erosion or through runoff or leaching losses and tile lines. So how's that carbon moving out of our fields? And so what we'll talk about is a web-based tool, the hydrologic characterization tool. And this is a web-based tool that we've developed in Project JD and I have been on for the last 4 years, the SEEP project. Originally it was Paradise Creek, and then we've moved on to the synthesis of all the SEEP projects across the country. So this is a tool for, a decision support tool to actually look at the hydrology within different regions. So, okay, so talk about erosion on the Palouse. You have to have a big erosion picture from history, days gone by. We've come a long way from these days of massive erosion. We've moved a lot of soil carbon over the years across the Palouse. You can see some massive deposition that had gone on. If you can see the shovel in the middle of that picture, there's been a lot of soil movement. But we've learned that you put more residue on the soil, plow on the contour, or don't plow at all. You know, plant this thing, we've got to put it in the no-till, leave that residue on, and we see soil erosion rates have gone down dramatically. And it's probably one of the biggest success stories around the country is a reduction in soil erosion in the Palouse area. So that's good. Bad thing is there's actually still erosion going on, and the hydrology in the Palouse area is actually fairly complex. And sometimes even under no-till, we're seeing erosion. This upper left picture is actually from the Cook farm, so we're having runoff and erosion on a continuous no-till, and you see in the lower right picture there is actually a perennial grassland. That's in CRP. We're actually having gullies forming. So we still see some of this going on. A lot of this has to do with the soils itself. A lot of the soils in the Palouse have a restrictive layer, or is an argillic layer of some sort that restricts water movement. And so the amount of runoff we have is really dependent on where these layers are and how they sit in the landscape. You can see these layers have different, they're very noticeable in the soil. And so you can see these saturation patterns at the bottom of the hill slope where you can actually see water seeping over the top of these layers. So it's fairly complex. So if you're looking at trying to reduce further erosion, you really have to understand the hydrology pretty well. And especially if you want to start looking at carbon export as well, we need to understand what's going on within a hill slope. So at this point, a lot of the soil management decisions, where we put a management practice and how effective a management practice is very general. And so there's really a need for site-specific decision support tools to assess the effectiveness at the Hillslope-scale. And in this case, we can actually adapt this technique, this tool that we have, and actually put soil carbon export into it. And so that's what we were trying to go for. This hydrologic characterization tool, it's mainly a kind of, it's supposed to be a simple, user-friendly type tool that you can use on a hill slope. Behind this hydrologic characterization tool is the WET model. It's a soil hydrology model, hill slope based. And so the way the web page is set up now is you can select a region, and how I visualize this developing is you can select an AEZ. So where are you at in the Palouse? Select your AEZ. You can come in and then you can select a specific climate file. We could use actually observed data, or we can generate this climate data. You can select a type of slope steepness, and you may want to select even 3 or 4 different runs. So I have a flat slope. I have slopes up to 35%. Maybe I have a moderate slope too. You can select multiple slope types. And then how it works is that it actually has an upslope, midslope, and downslope percentages. So you can go within a slope. So like the steep there is 5% upper slope, 35 midslope, 5% toe slope. So it's a hill slope representation. You can select a soil type, and we've incorporated the depth to a restrictive layer in there. So you can actually get your specific soil type, whether a shallow soil or a deep soil. You can select a crop rotation. So I have a winter wheat barley pea, or I have a winter wheat fallow. You can select either a mulch till or no-till or conventional till, or if you have a grass buffer. So you can actually select some common management practice. Then you can run the model for any number of years. Typically, we have 30-year simulations. Now, what you get out of it is relative predictions of soil erosion. And here I'm showing the blue is for a shallow soil. The red is an intermediate soil depth. And the yellow is a deep soil depth. And you can see for the right, the conventional tillage, you see for really shallow soils, you can have some massive erosion rates going on under conventional tillage. You put a buffer at the bottom, we're still at 20 tons per hectare per year, which is pretty good soil erosion rate. So if you have these shallow soils, you almost have to go to no-till before you get to significant declining soil erosion. You can see with the deeper soils, than mulch till, you almost eliminate most of it. And so you can see that the tool can let you visualize in your AEZ how sensitive it is to type of tillage. The tool also lets you look at the monthly distribution. So if you want to know when is this occurring at, and actually how is the water moving? Is it surface runoff, or is it subsurface lateral flow, or if it's percolation? And you can also look at even within a hill slope, where is the soil erosion and runoff happening at within this slope. So I can see this is a tool that we're going to develop it, incorporate the soil carbon into it. We're trying to work with Claudio, trying to get the same management files into it. We want to actually populate it with the carbon values that are representative of the region, each AEZ, and we want to assess the accuracy of it. And so part of the monitoring is actually focused on the Palouse Basin. I'm going fast because I got the 1-minute signal. The model can use soil organic matter measurements to actually get at within each AEZ has a certain amount of carbon within there. And we're actually looking at identifying the export of carbon by water and different AEZs within the region itself. So I'm done.